So, hello everybody, nice to be here. I'm Mateusz Szostok, a senior software engineer at SAP Labs Poland. On daily basis, I'm QA maintainer, but I'm also maintainer and co-chair of SIG Service Catalog. This is a deep dive session about Service Catalog. Yesterday, we have intro session where Jonathan explained what Service Catalog is and why you would want one. During this session, you will learn what is Open Service Broker API specification. Next, I will present the current status of CRD implementation. I want to also say a few words about our release process because we changed it a little bit, so I want to say how it affects you. Additionally, I will briefly show you which new sub-projects were added under the SIG Service Catalog control. Then we'll jump into proposal for service instance deletion. And last but not least, I will introduce you to our plan for upcoming 0.2, 0.3 release. So let's start with Open Service Broker API specification. So this specification defines the REST API, which allows cloud, in our case Kubernetes, interact with service brokers. Service broker is a server somewhere on the internet that offers catalog of services. Service Catalog is a client implementation where you can register your broker. As a result, you will have a one place which is unified and where you can find all of your services. And what is service? So service can be pretty much anything. A classical example is database. How do I get one? Do you remember the old approach where you were creating a ticket to infra team and waiting until it's resolved and then get your credentials back? It's not a way to go with cloud native world. We want to have something managed, but also automated. And in ecosystem, we have a GCP broker. That broker you can register in Service Catalog. As a result, you will see GCP offering in your cluster. So you can say, hey, create me a MySQL database on GCP side, and then get me back the credentials. And you as a user don't care how it's managed or maintained. You can focus on writing your business application. And it could be also extend to other use cases like subscribing to some APIs. For example, Azure Broker allows you to subscribe to text analytics service, which is also cool. You can create also your own broker. For example, in Kema, we created a broker which allows you to expose APIs and events from some monolith application into your cluster. So, as I said, this specification is about REST APIs. So, we communicated between Service Catalog and brokers using REST calls. We have catalog endpoint, we have endpoint to provision the service, we have endpoint to create a binding, unbinding, deprovision, and delete that and update that instance. So, as you can see, it's simple and awesome concept. But when you want to extend Kubernetes, you should, in a native way, of course, you should add a new kinds and a controller manager, which is watching those kinds and based on that, execute some actions. So, in Service Catalog, we added 8 kinds. First of all, we created cluster service broker. When you want to register a broker in your platform, you need to create cluster service broker. In case of that kind, you will see services from given broker in the whole cluster. But what you can do also is to create a service broker. As a result, you will see services from that broker only in a given namespace. As a side note, you can also define cluster restriction. So you can filter out some service classes from a given broker. Okay, so when you register a broker, then Service Catalog fetches services from a given broker and represent them as service classes and service plans in your cluster. And service class can be like MySQL, and each service class has at least one plan. And plan is like free tier or enterprise edition where you can adjust your database size, right? After that, you can create a service instance for a given class. So service instance is like a physical MySQL installation. And after that, you're creating service binding to get your credential to that instance. So as I said, Service Catalog extends Kubernetes by adding new kinds. But how? To answer that question, I need to say that this project was started by Google guys almost 3 years ago. At that time, we are able to extend Kubernetes only using aggregated API server. And who knows what it is? Okay, so I will briefly describe it. Basically, if you are operating on the core resources, you are going through the main API server, and your manifests are stored in the main etcd storage. When it comes to extend that with aggregated API server, you need to deploy your server and have etcd storage, where your manifest will be stored. And it sounds okay-ish, but we had a few problems when it comes to maintaining and developing service catalog. First of all, as I said, you need to write API server from scratch. So basically, you need to write strategy for each of your kind and also DB connection. You own a lot of code, and the problem is that this code is not directly connected with your business application. Second thing is that if you own the whole API logic, then you also own some core concepts, like incrementing generation field. Simply, you duplicate core logic, which is, leads to some bugs, and it's hard to follow best practices. The last thing that I want to talk about is that in this approach, you need to have etcd connection. So you need to have your etc cluster and maintain backups, upgrades, and so on and so forth. So we have a new kid on the block, CRDs. CRDs are right now in GA stage. So how hard could it be? With CRDs, it's like a child's play. You define name and version, and as a result, your kind is registered in the main API server. So anyone who creates your kind, and then this call goes directly through the main API server, and your manifests are stored in the main API etcd storage. So it allows you to benefit from the implementation improvement of the general API server, which is really cool. So in the new service catalog version, we get rid of the API server and etcd storage and replace that with the CRD approach. We also added webhook server, which allows us to intercept CRUD requests, so we can set some defaults or validate manifests before storing them in etcd. So right now we know the building blocks of new architecture, and now I need to answer how did we move our features. So at the beginning, we collected all aggregated API server features. On the slide, you see only the 5 most important ones, and the whole story took us around 5 months, so it was hard to squeeze 5 months of work into 30-minute talk. So I will focus only how we substituted field selector in the CRD approach. Why? Because in my opinion, it was the most problematic part, and also it affects you as a user. So as an introduction, for those who don't know, field selector allows you to fetch resources with the same field value. We strongly rely on such queries in our project. Unfortunately, we are not able to query CRDs using field selector. We need to find out some alternatives. And of course, there are some other options that we considered, but I will describe only that one that was finally implemented. And you work with Kubernetes, so you know that we can query resources using label selector. So what we did, we simply copied those fields under labels entry. And similar approach is also implemented in Prow. And what you need to know is that there are some restrictions about labels values. So first off, it's limited to 63 characters and has strict rules about characters that are allowed. At the beginning, we forget about that, but now we already fixed that just by doing the SHA from given value. As a result, we have always fixed number of characters, and we are escaping not allowed characters by default. So previously, we had a field selector. Right now, we have a label selector when you need to specify the label name and also label value. So if you are querying resources from service catalog using field selector, please replace that with label selector. As I said, we don't have enough time to go through all of our migration scenarios, but here you will find a recording from this year's Cloud Native conference where I talk about our migration approach in details, and I encourage you to watch that recording. And now let's go back to what we have already achieved. So exactly on the 3rd of October, we cut off the first beta release. The purpose of the beta release is to get the feedback from the community, as well as give you a chance to test Service Catalog in stage environments before the 0.3 is officially released. And now we have the third beta release where a lot of things were already fixed. And I need to say that we create a new one because we need to fix the cleaner job. Basically, right now we are not working on Kubernetes 1.16 because in 1.16, duplicate APIs were removed from Kubernetes and we need to update our clients. So let's say a few words how those plans affect you. First of all, the old implementation is still available on 0.2 branch, and we support that implementation until July 2020. We provide bug and security fixes for that implementation. Because we are supporting two versions at the same time, we had to adjust our pipeline just a little bit. The release process from the master branch looks exactly as previously. So commits from master have two tags, canary and specific name for the commit. In case of a release, we are also pushing helm chart to our registry using the catalog name. Be aware that we also supporting the release from 0.2 branch, but here the release with deprecated API server has the 0.2 suffix. So it also applies to a chart that is pushed to our registry. And same thing applies to SVCAT binaries. Here you have helm commands that can be used to install Service Catalog in given version. So from master, it's exactly as same as previously. And in case of the old approach, you need to specify the 0.2 suffix. So we have already a new implementation. And we also created the migration job, which takes care of migrating your resources from a Grid API server to CRD approach. We integrated that job into our Helm chart, so you can simply execute Helm upgrade command, and as a result, you will have new Service Catalog on your server. But we also created dedicated documentation how to execute our migration binary manually. So in case you didn't install Service Catalog using Helm charts, be aware that you need to execute a sanity check before doing the migration. You cannot have any ongoing async operation, and also you cannot have any resources which are failed during the deletion process. If you have such resources in your cluster, you may run into some corner cases during the migration process. Nevertheless, I really encourage you to test the new Service Catalog and share the feedback with us. I can say that Kima project already uses Service Catalog with CRD implementation on the production environments. Next topic, new sub-projects under Service Catalog. So some time ago, we moved two projects under our control. First one is Mini Broker. We are using it in official Service Catalog workflow documentation, and basically that broker is really nice for local development and testing scenarios. Second thing is Go client for service brokers. We use that client in our Service Catalog controllers, and it's also right now under the Kubernetes 6 organization. The last thing is that we finally migrated from deprecated Kubernetes incubator organization to Kubernetes 6. So do not forget to update your fork projects location on your local machines. Now it's time to jump into design issue. So as an introduction, I need to say that, for example, you have a service instance, and after that, you created some service binding to that service instance. After some time, you decide, okay, I don't need that instance, so what I need to do is simply delete that service instance. But the provision process will fail because you still have some associated service bindings to that service instance. The problem is that the service instance is already marked for deletion, and we cannot revert that state. As a result, you are not able to update that service instance or create a new service binding. So the current behavior is so-so. So there was already a lot of discussion about that problem. So around 1 month ago, we created a new proposal which described the current problems that we have and gather all options that were previously discussed and show the accepted solution. And the accepted solution is to add cascade deletion. Because we get a feedback from the most of our users that users expect that deleting a Kubernetes resource results in total deletion of resources associated with it. So for example, you have deployment, and when you delete deployment, then also underlying pods are also deleted. It's not exactly the same in Service Catalog, but we still decide to go with that approach. So right now, you have an option to specify flag during the Service Catalog installation, and then Control Manager will always perform the cascade deletion for your service instance. Is there any alternative? Other options is to deal with this issue is to implement the proper validation webhook, so we can reject the deletion request before reaching the main API server. And if you use the Service Catalog and have some thoughts about it, just please share them with us under the issue about cascade deletion. And almost the last point on my presentation, and I want to talk right now about our plans for Audit 2 milestone. So first of all, we want to work on our documentation enhancement. We want to be compliant with official guidelines. We also want to clean up our structure, add more examples, and also update our main README because it's a little bit outdated, and we want to show new things that were added during the developing process. Yeah, very important thing, we also want to be compliant with new Open Service Broker API specification. CI pipelines cleanup, and that's true. We already did a lot of work, a lot of things regarding CI pipelines. We added end-to-end and migration tests. We adjusted our building pipelines on Prow. And right now, we are thinking about moving our release pipeline from Travis to Prow. So thanks to that, we will have more control over that process. And of course, add documentation about our continuous integration flows, which will be really helpful for our new contributors. Next thing, migrate Service Catalog resources under our control. Currently, our website is controlled by one of our maintainers, and we simply want to move it to something that is really connected with SIG, so under the SIG domain. Last thing really important for us is also to have a final decision about the pod preset functionality. So right now, when you are creating a service binding, we are fetching credentials from broker and storing them in Kubernetes secret. After that, you need to manually inject those secrets into your business application. What we want to do is to do that in automated way. To do so, we wanted to reuse pod preset functionality, but right now, pod presets are still in alpha state in Kubernetes, so we need to sync with SIG API machinery and SIG architecture about the future of those resources. And maybe we just simply move those functionality under the SIG Service Catalog control. But a lot of discussion needs to be done before announcing the final decision. So as you can see, a lot of things going on. And if you want to become the contributor, then just join our weekly SIG meetings. It takes place each Monday at 9 a.m. Pacific time. So it's 6 p.m. for Central Europe. And here you have also some useful links for our homepage, for GitHub repo, and links for our communication channels. The presentation is available on the KubeCon site, so you can download it from there. And thank you for your time, and now I'm open for your questions. Okay. Okay. Hi.
I'd like to know what do you think about the major cloud providers following up with this service catalog approach? I see major cloud providers going in different directions, such as operators or different approaches. What do you think about it? Do you think they will follow to support and get engaged with service catalog about provisioning resources in the cloud providers?
So the question was, in which direction the cloud providers are going? So if they want to invest time to support some dedicated brokers, or if they want to go with dedicated operators, right? Okay. So we still don't have the final decision about that, and I need to say that we still have GCP brokers, Azure brokers, AWS brokers present in the ecosystem, and they are still developed. We have some contacts with GCP guys which are still developing that thing, because the main reason is that if you are developing some controllers, like operators, you can run them only in Kubernetes ecosystem. With service brokers, it's really agnostic. So you can you can simply implement it only once, and your offering will be available on the Kubernetes, on Cloud Foundry. And right now, even in SAP, there is something like Service Manager, which exposes services from SAP directly to Cloud Foundry and also Kubernetes. So the main reason to invest time in service brokers is to be agnostic between your platform. And currently, we are just developing Service Catalog. We are not so close to service brokers, but from my experience as a Kima developer, I can say that right now we still using a lot of brokers from ecosystem, and they are still active.
Okay, and my last question is, does this new CRD approach solve the RBAC problem that we had previously? Like, we can't just define RBAC rules since it's all service instance. For example, I want to give some user the rights to provision a database, but not a bucket, for example. But since it's all a service instance, it's all the same from the user perspective.
Yeah, I get your point. So basically, CRDs does not solve those problems. CRDs solve problems with etc that we required at the beginning, etcd connections. So you need to maintain some etc cluster in case of managed Kubernetes platform. And about your problem, what you can do right now is to create a dedicated namespace per user that will provision some instance, because what you can do right now, you can create a service broker, which is namespace scoped, and then you can also filter out some services that you don't want to expose to the end user. That's the current thing that you can implement, but right now we didn't solve the RBAC issue. Yep. But right now, still in Kubernetes ecosystem, CRDs are really promoted, and you need to really have a specific case to use the aggregate API server, right? Basically, you will generate additional load on your main API server, but to be honest, it's not so big to have a problems with that. And if you want to go with aggregate API server, it's good for some some really specific use cases when you want to change the some core logic, right? You need to adjust it a little bit, or you want to still support the field selector queries, or you want to have some additional generic sub-resources. With CRDs, you can only support status, scale, and I think that's it. So only 2 sub-resources on your kind. But basically, if you check the Kubernetes recommendation, mostly it's good to go with CRD's approach because, as I said, it allows you to benefit from the main improvements in the general API server instead of doing a lot of work directly in your project.
Yeah, you would have used CRDs if you could have when you did CRDs too. It's just you couldn't do it.
Once again?
You couldn't do the CRD approach. When you came out with 0.2, it wasn't Kubernetes, you couldn't do that.
Yeah, that's true. Yeah, that's also true.
One thing you might also want to mention is that you only actually cause additional traffic on the SCD when you provision client service instances, which is like a infrequent operation, it's a constructive operation. Once that has happened and your applications are actually using the service instances, that doesn't go through SCD at all.
Yeah, that's also true. So it's only for provisioning and mining actions. And still in the aggregate API server, you're also going through the main API server, so you're also generating some loads on the main API server. That's true. Any other? Okay. Okay, so basically, do you know what pod presets are? Okay. So simply, right now in Kuma project, we have something like service binding usage. And our idea behind that is to say during the binding action, you can already specify in which deployment functions or whatever, those bindings will be, so those secrets will be automatically injected. So as a result, you don't need to take care of somehow adjusting your deployments to have additional environments variable, and you need to change it because your deployments stay as they are, and secrets are automatically available in your deployment. So right now, we're just using pod preset to say, hey, just inject those secrets from Kubernetes directly into your pod. As a result, you have environment variables from a given broker directly in your business application. There is one problem with that approach, that you need to know the name of the secret, that still you need to know the exact name of the secrets. So for example, it will be host or username, password. We don't have any contract between our services. So if you provision service, MySQL service from Azure, and then you will replace that with the MySQL from Google, those credentials may be different. But probably maybe, correct me if I'm wrong, the Open Service Broker API will work on that.
Yeah, so OSB API, the API that Service Broker is an implementation of, one of the features we're currently working on is allowing broker authors to specify this service adheres to some form in the way its credentials are presented. So maybe we have an official format for what database credentials look like. It has to have a host name, a port number, a username, and a password, or something like that. So that way, it would allow the platform and our service catalog to more intelligently manage how those credentials will be consumed by end user applications.
So the result of the binding that would be a secret and a pod user.
Yeah.
Yeah, the second approach for that is also that not force every end user program to have a contract, for example, for MySQL resources. The other way of doing that is a transformation that could be defined by the user, that this URL environment variable will be renamed to something else that really fits to your application. Then it could be also considered, but yeah, the best it will be defined on the Open Service Broker API.
Yeah. Any other questions?
You said earlier that you guys talked to the release process or the release cadence. Maybe I understand security, but where do you, I guess, let me turn it into a question. What is there going to be like an anticipated release cadence that you all
Okay, so yes. So first of all, Service Catalog is still in like a beta phase, right? So we don't have official release 1.0, and right now we are doing the milestones, and right now currently we are implementing 0.3 milestones. And what we did right now, we use the same version option to somehow say to our user, hey, it's still beta, but right now in that beta we have like an alpha version that say that current CRD approach needs to be tested on your stage environments before we'll officially release 0.3. Simple, only 0.3 release, which means that it's a beta, but a stable beta that you can use on production clusters. But yeah, there's two steps, and you can read more about it using on some versioning site. So you will know that if we are adding additional suffix beta, then you inform user that do not use that implementation directly on your production servers, but still try it out on your some stage environments and report some issues. And I'm not quite sure, I don't want to do any promise, but yeah, we are working to get to 1.0. Few things needs to be adjusted. For example, still the pod preset needs to be defined, how we want to work on that or not. And also our documentation needs to be cleaned up before going to 0.1. Okay, so no more questions. Thank you very much for your time, and see you on the next KubeCon.